Good morning, students, afternoon, whatever time that you're watching. What we're doing today is we're looking at one of Savannah's research that she had submitted. I don't know who all watched this, so I'll not use Savannah's last name. This is just taking what she had presented and building upon it. This is, she called it the dehydration of sugar. And that is essentially what it is. A former colleague of mine, Mr. Funderburg, called it the carbon cookie. So I wanted to show you what that looked like. We'll look over here in just a minute. I set one up originally, and this is what took place. The powder that you see around that is from the baking soda, which, if you remember from our study, is sodium bicarbonate, or sodium hydrogen carbonate if you're using the stock system. We're using concentrated sulfuric acid, which is 18 molar concentration. I'm using 70 milliliters of that, which is in excess, as we'll see on the moment in the board. This is sucrose, which is C12H22O11, and what you're going to see is it get hot enough to change it from being a sugar form which has hydrogen and oxygen in it to removing those two components and leaving just carbon. It's pretty interesting to look at. I'm going to look over here at the board for just a minute, and then we'll get the actual demonstration. The beaker I chose is the 150 milliliter because on my balance the 250 was too much mass, so I added the mass here. I put the re-zero mechanism on our balance and added the sucrose to that. That's what you saw over there on the screen there, or over on the vent hood. The equation, as you can see, has the steps that we've incorporated that we've done before. We have the balanced equation in case some of you forgot what subscripts were. I've got those pointed out to you. I've got the coefficients pointed over here. We always start with something that's known, which in this case is the sucrose that we can measure. And then we go through a series of steps whereby each of these can be made in a conversion factor equal to 1, that 1 mole of sugar, and this is how you do the conversion from the atomic atomic masses on the periodic table. You add those each together and you get this, and you need to practice that if you haven't already. These two numbers here, the 1 and the 1, is not a 1 because this is a 1, but it's a 1 based upon these coefficients here. And so that's why that, based on the fact that this side is equal to that side, we can say that's equal to 1. And then of course, the last step, converting it to the substance that we could measure. But as you saw in the results of the first one, the demonstration, that we had some residual that came out of the beaker onto the newspaper, which would mean I'd lose some of my product. So taking that mass and adding it back over here to count the 2.46 predicted mass, we would have a % error on that, and you remember how we calculated that in class. So I'm going to pour the acid in there next and let you see what takes place. Guess my time's up. We're adding the sulfuric acid. Now I use a stirring rod, and you'll notice the caramelization will start almost immediately. It'll start darkening. See it becoming darker in color. And I'll hesitate to turn on the vent hood until it actually starts generating enough heat. As we can see, that was predicted in our equation that we would release a lot of heat. So you'll see dehydration occurring. You'll see this darkening continue to occur, and then you'll see steam arising as the sugar is decomposed to make carbon, which will make this product here that you see protruding here out of the beaker. So it looks like it's moving right along, starting to get very warm. This is where we need the theme to Jeopardy going on right now while we're waiting for this to go. Appreciate Miss Brown as she's graciously giving up her time to assist in this endeavor. And we'll see if things work out well. We may try to do a few more if y'all like this. So we'll see how it goes. I see some bubbling occurring, so that means that some of the decomposition is occurring. See it starting to come up, splattering. Alright, it's continuing to evaporate. We'll look at that just a little bit. I've got one little thing I'd like for Ms. Brown to catch over here for you guys to think about. What safety steps did you observe? Do you remember how to calculate the formula masses for the substances? Will you practice so that you can remember all these steps here? Did you notice any problem areas? I pointed out a couple of them. So maybe you noticed something else that you would care to make a comment on. So feel free to do that. Let me move over, and I got one more slide and then I'll be done. Some of you are actually still working on your projects, and you may not have access to internet. I don't know, but you can incorporate some of these steps, the steps of the stoichiometry that you saw on the board. You can try to practice those, and if you have questions, you can try to email me and that type of thing. If that doesn't work, still do the best you can. You can go online and ask each other different things. So feel free to ask, and hope you enjoyed this. Have a good day.